Cool, looks like we're going. So still looking at the downloader in Geth again. Give me Geth. We went through some of these fetches, and this last bit here, so the last function that gets called is either fast process sync content or process full sync content. Process fast sync content or process full, depending on if it's in fast mode or full sync. And that's probably, like, I'm just trying to vaguely look for where the differences between fast sync and full sync are. I thought for some reason that fast sync didn't actually get the blocks, it just got the headers, but that might be light mode. That might be where I was originally wrong, and this might be the only difference. And it might just be that the processing of the blocks is different. Like, the processing of headers is the same, but the blocks. So we'll start with, I'll save this spot, process full sync content. And this is absolutely tiny. I love seeing this. There's not too much to go through. So results equals DQ results. So downloader has a queue going. And imagine if I go up here. No, there is a results. Results is a function. Retrieves and permanently removes a block of fetch results from the cache. The resultant slice will be empty if the queue has been closed. So I might dig a little bit more into this queue that's being maintained. So up the top here, when they define the actual structure, I'm assuming there's a queue. I've seen it come up a couple times, but I haven't. Yeah, there it is. Queue. And imagine if there's a new downloader, it makes a new queue that's empty. Yeah, it calls new queue. Slash new QE. Has a header pending pool, block task pool, block pending pool, block done pool. And these are all channels. No, they're not all channels. There's one channel. The rest are just maps from hashes to fetch requests in the case of a receipts a type header, and block task a type header, and pending is a fetch request. So I guess if we look back at here, it looks for queue results. Let me go back to here. Count of processable items. So it's count processable items. It counts how many is in the result cache. So what was the result cache? A, B, C, D. Downloaded but not yet delivered fetch results. Cool. Processable items. So it gets the number of items that are in results. If it's closed and no block, return nil. If the number of processes are above the max results process. What's max results process then? It's not there. So if we go into eth/downloader ac max results process 248 2048 2048 number of download results to import at once into the chain. Results takes from the queue and returns an array of fetch results. And an chain insert hook. No, okay, that's if chain insert hook. So you can call stuff before it goes into it, but then it's import block results. Results equals an array of fetch results to the length of process, which is the max process here. So 2048 is the max, but if you got less than that, cool. If it's greater than 0, range in results. So I guess I got to figure out what a fetch result is, don't I? Is a structure collecting partial results. So we've got a hash, a header, and uncalled transactions. So it's pretty much a block. They just got an array of what is everything to be a block. Maybe. I don't think they probably use them all at once. So they get the hash from the header. Delete. Block done pool. Delete. Okay, cool. Whatever that means. You delete it from the pool. What's delete doing? Golang. Deletes the element within the specified key map. Cool. So it just removes it from the map, the hash. Delete the results from the cache and clear the tail. Okay, so you got your cache, and they're deleting everything up till end post, so it's up to 2048 if there's that many, but doesn't look like it. For I equals length result cache. So location in pro. Copy into results up to that number. So the cache in the results. We're working on the cache at the moment. So this bit here just deletes to block done pull, receipt done pull. Just deletes it out. Delete the results from the cache and clear the tail. For I equals length result cache minus n prog. So they set the first I equals length. So they start at n minus 2448. At less than the full length, they set that result to 0. So this cache must be a full set length all the time, and they want it to be nil. So that's what they mean by clearing the tail. Advance the expected block number of the first cache. Result offset equals nprog. Recalculate the result item weights to prevent any memory exhaustion. Result equals range results. So they go through and they calculate the size of the headers, the uncles, the receipts, and the transactions. And then after that's done, just returns the results. So after all that, it's really just, they've got this queue where they're saving everything. When things are being downloaded, they save it to this queue. And it does nothing at this point. But it just holds the stuff before they put it into the actual blockchain. So they go there and they grab some items off of it. And if it's a lot there, they only take 2048. If it's less than that, they take all of them. And then they make sure this cache that's in this queue is cleared and good to go. And I think that just must take a lot of effort. For results true. So what's the true do? What's the boolean? Block. If not block, return nil. If length to results equals 0, insert chain hook. I'm not going to follow that, but I imagine it's calling some functions whenever there's new blocks being imported, and they call import block results on the downloader, which is right below it. So they've got an array of structures, these fetch results. And these fetch results have it's pretty much a block. but in a weird structure, so it's not fully exactly in it. Retrieve a batch of results to import. First and last, so they get the header of the first and the header of the last. They do the normal bullshit. If the quit channel has been set, then they don't do it. If the length of results equals 0, then they don't do it. And they call inserting downloaded chain. They log it. First number, last number. Blocks equals make. So much going on there. These traces. Unsolicited replies. So my is just really getting errors because it's getting no replies from. Nodes. Failed RLPX. Cool. Anyway, so they get the block first and last, and they make a log over here that'll say how many he's got. Blocks equals make. Type blocks, length results. So they're making the actual initial block an array of blocks. For I in result, for results, block that number equals new block with header, passing the header, dot with body, the transaction, and the uncles. And that is all. Blockchain insert chain blocks. So somewhere in this blockchain up here, it's in core blockchain. They call insert chain. Attempts to insert the given batch of blocks into the canonical chain. And it's tiny. Because they call it, there's a wrapper. Damn it. So insert chain will execute the actual chain insertion and event aggregation. The only reason this exists as a separate function is to make the locking cleaner with deferred. Fair enough. So you've got a chain of blocks. So they've got type blocks as a chain. I guess chain is just an array of blocks. If chain I so they go through the length of the chain. If chain I, so they start at 1, they skip 0, does not equal the number of the previous one plus 1, or the parent hash does not equal the last one's hash, skip insertion. Ember, non-contiguous block insert. So it goes down there. Yeah. And they return some errors. Cool. Add a work group. So work group's just a way of keeping track how many processes you're spinning up. And you have to wait till work group 0 for some if you want. It just makes it easier to say, look, I want everything else that's been started to be stopped first. Otherwise, your program might even finalize. If you're running a program and you're spinning up processes, and then it gets to the end of your code, it'll stop even though there's processes running on the side. So you make a work group and you wait till they get to 0 before you stop. And that sort of gets more complicated when you spin up heaps of different programs. Pre-checks passed, start the full block inputs. A queued approach to delivering events. I don't know what that means. What are they doing? Nothing. Headers equals make. So they start a parallel header verifier. So they got headers, the length of the chain. For I, comma, block in range chain, header I, seals I equals true. bc.engine.verify headers. So the engine is ETH hash in this case. Consensus cd ETH hash ACK verify headers. In 106. So it verifies a batch of headers. Proof of work mode equals full fake. Which it's not, I hope. Spawn as many workers as allowed threads. Go max procedures 0. If the length of the headers is less than workers, so they're figuring out how many workers they're going to spin up. Create a task channel and spawn the verifiers. So for I, what's inputs? Make channel int. Channel of integers. Errors index. Verify header worker. So start a header worker. with the chain headers seal. Because I think there's only one in there for each worker. I mean, I guess that must be true. Let's see what a for loop over how for and range iterate over base. We can use this to iterate over a structure. Make channel string 1, 2 for elements in range Q. So calls verify header worker chain. Done, goes to index. I reckon this loops. Because this first one's got nothing on the channel. Errors out. Defer close inputs. Variables. Checked equals the length of the headers. So this is where they're actually putting it into the inputs. For there's an I going into inputs. Case index is done. Case abort. So alright, so they're calling verify header worker. It's the main function that's doing the work. And in it they've got a array of headers. You've got a parent, which is a type header, index equals 0, parent equals get header. Else if, so they figure out what the parent is. If it's the first one, they have to go get it from the blockchain themselves, which is here. So they go to chain and get header. Else if it'll equal the one below it. If parent equals nil, unknown ancestor. Fair enough. Chain.get header. They check if it already exists. They call verify header. On that one. So what does that mean? Verify header. So why is that one not right below it? Here it is. Header conforms to consensus rules of the stock engine. verify header. Chain consensus. They got a header and a parent in here. Is this big? Yeah, cool. So this bit actually goes through if there's a maximum extra data size. Extra data too long, fails. Header's timestamp. If the time is greater than is bigger than the max big 256, then it's too big. Error future block. Error 0 block size. 0 block time. So here they're just checking that the time isn't screwed up. And then verify the block's difficulty based on its timestamp and parent difficulty. ETH hash calculate difficulty, chain header parent. Chain header dot time parent. So this would take the parent and the time that the new one is and the expected difficulty. So if it's less than 12 seconds, they increase the difficulty. If it's more, they reduce it. If expected header difficulty does not equal 0, so if the difficulty does not match what's in the header, they have the wrong difficulty. Verify the gas limit is less than or equal to the biggest one. Verify the gas used is less than the gas limit. Verify that the gas limit is within the allowed bound. Difference equals the parent's gas limit minus the new gas limit. If the difficulty is less than 0, diff equals -1. Limit equals parent gas limit divided by gas limit bound divisor. Okay, so there's a limit to how much you can change your gas limit on the parents. What does that mean? Go lang. No, not going. Yes. Where's the yellow paper? Bloody hell. The header of the parent, if the header is less than the parent plus divided by 1024. It must be plus or minus 1024. I guess. That's how I'm reading that. If I go up into params, I don't know where it's going to be. Gas table, boot notes. Yeah, okay. So the bound divisor of the gas limit. So it pretty much says that the parent divided by 1024, you can only be plus or minus that from the parent. So must be less than the parent header plus 1024, or greater than the header minus 1024. And it also must be greater than or equal to 125000. I think. Depends what header T is. I'm assuming that means the header gas limit. Oh, the gas limit HT. Yeah, cool. So this is where they check that the gas limit is right. Verify the block's parent is +1. Verify the engine specific seal secured block. If seal, verify seal chain header. So I don't know what verify seal is. I'm not going to look at that today. Full checks pass. Validate any special fields for hard forks. Verify DAO extra header data. Verify fork hashes. Cool. So it really just goes through, make sure that the parent is right, make sure that the difficulty is right, make sure that the gas is right. So they call verify headers. And abort is a channel, I guess, that can do it. The results come back. Recover from blocks. So ignore that. Let's look at this bit here, which seems much more important. For blocking the chain, if the chain is terminating, ignore that. If the header is a banned one, straight out abort. If you get a blacklisted hash, straight out abort. BC report block. Bad block. Chain config. So it spits a proper error out of you. Fun. Wait for the block verification to complete. Stuff comes back into results. Blockchain validator, validate body. I guess that's Ethash. Core types. So it goes into this types and looks for validate body. Oh. Block validator. In core block validator. So it's just this one function in this file. Very good, very good. That was our calculate gas limit. Validate state, validate blocks. Body. Given a block's uncles and verities. Block header transaction and uncle roots. The headers are assumed to be already validated at this point, which they have been. We saw that happen before. And then it calls validate body on the block that's been sent. Cool. Blockchain has block and state. Error known block. Cool. So if it already knows it's there, it spits an error. It says we already know this block. Has block and state. Parent hash. If it has the parent, no, if it does not have the parent, that means it is an unknown ancestor or a pruned ancestor. I don't want to dig into that, but header validity is known at this point. Check the uncles and transactions. So they get the header, call verify uncles, and then calculate uncle hash. So ENS, ETH, and that was at 184. Oh, I saw this one before. Verify that there are most 2 uncles included in this block. Checks that the ancestors don't already exist. Verify each of the uncles that it's recent but not an ancestor. Cool. I don't want to dig too much more than that because uncles aren't super important. So they just check, reading these, that there's only 2 in the block, that it's not doubled up, and that it's recent. So it must be less than or equal to 8 or something, I think it is, blocks before it. And if it is, then it's good. Just make sure it's not an ancestor. Cool. So to verify the uncles, calculate the hash on the uncles if they're good. Uncle root hash have a mismatch. calculate uncle hash. Yeah, so check. I wonder if that's a... No, not directly. I can't bother. For uncles anyway. Calculate uncle hash. We'll take all the uncles that are in the block and do the hash that gets saved in there. The root hash. Puts it in a tree and stuff. So then it actually gets the transactions in the block and make sure it matches what's in the header for the hash. And if any of those things, it returns nil. If it doesn't, it returns an error. Else it returns nil, which is good. Validate body. Switch if there's an error equals error known block. Consensus future error future block. So if there are errors, they deal with them sometimes. Create a new state database. So that's the switch statement. That's all the checks. Now we create a new state database using the parent block and report an error if it fails. Blockchain get block for parent hash. Parent equals chain I minus 1. So they've built up I at some point. Then process the block using parent state as a reference. Receipts, logs, use gas, blockchain processor, process block state. So I guess in here there's a processor. New state processor. BC processor. State processor, here it is. Processes the state change according to the rules. We don't need that anymore. So they call process. No, we did need another one. Okay. Reddit receipts, not Reddit. Used gas header. Block state returns the receipt type of logs. Mutate the block and state according to any hard fork specs. So if there's a hard block, they deal with it here. Iterate over and process the individual transactions. So they go through each of the transactions here. State database prepare hash block. Cool. This is starting to get really deep into the processing of the state. So I might call it there, because I don't want to go too much more into the state. I think tomorrow I'll go look at the blockchain structure itself, just because it keeps coming back to it now, and it's pretty big. It is pretty big, but you know, there's a lot of stuff in there that keep getting called and probably should be looked at. Blockchain structure. Cool. Anyway, thanks guys. Take care.